In my last presentation, I have shown you how to design a multiplexer. In this video, I will show you how to design 4:1 multiplexer. So this 4 indicates the number of input and 1 indicates the number of output in a multiplexer. Let me show you a block diagram of 4:1 multiplexer. So this is the block diagram of 4:1 multiplexer. In this multiplexer, it has 4 input labeled as I0, I1, I2 and I3. And you all know that every multiplexer has a single output only. Now, we are now going to connect each and every input with the output. So we require a dialer. So using this dialer, we connect each and every input with the common output. So this dialer can be connected with I0, or I1 or I2 or I3. So you can connect the output with any of the input. So how this dialer is working? The movement of the dialer depends upon the selector lines. So how many selector lines are required in this multiplexer? Here in this multiplexer there are 4 input. Let us consider the number of inputs is n, and here n is equal to 4. Now let m be the number of selector line. There is a relation between the input and the selector line. In my previous video, I have already mentioned the formula which relate the input and the selector lines. So this is the formula, m equal to log n with a base 2. So m is the number of selector line and n is the number of input line. As I have considered 4:1 multiplexer, that is the number of input is 4. So the n is 4 over here. So just put the value of n. So it will look like this, m equal to log 4 base 2. So 4 can be written as 2 to the power 2. The 2 in the power will come in front. So it will look like this, 2 into log 2 base 2. We all know that log a base a equal to 1. So log 2 base 2, it will become 1. So 2 into 1, it will give you 2. That is, 2 selector lines are required for 4:1 multiplexer. So S0 and S1, this is my 2 selector line which will drive the dialer. Now let's draw the truth table first. So this is my 4:1 MUX. It has 4 input, 1 output and 2 selector line. So the truth table will be look like this. So the truth table has 2 selector line S0 and S1 and it has an output Y. When S1 and S0 both are 0, the data at the I0 will pass through Y. That's mean I0 will pass through Y. That's why I have written I0 in the output column. In the same way, when S1 is 0 and S0 is 1, the data at the I1 input will direct to the Y output. That's why output will be I1 at that time. So when S1 is 0 and S0 is 0, it will select the I2 and pass it through the Y output. That's why Y will be I2. So when both S1 and S0 both are 1, it will select I3 and pass it to the Y output. So that's why Y will be I3 at that point of time. So this is the truth table of 4:1 multiplexer. With the help of this truth table, now we are going to write the Boolean function. So this is my Boolean function. Let me describe it. Okay. So look in the truth table, in the first row, S1 and S0 is 0. So for this combination of selector line, I0 will pass through Y output. So I have written S1 bar and S0 bar. Since both S1 and S0 are in a 0 state, so just write the selector variable with the invert symbol because both are 0. And it will be written along with I0. Now in the second row, S1 is 0 and S0 is 1. So S1 will be written as S1 bar, and since S0 is 1, so just simply write down S0 along with I1 input variable. So again write an OR operation because it is in the separate row. So there is another condition, S1 equal to 1 and S0 equal to 0. At that time I2 will pass through the output. So write S1 simply, and S0 is 0, so write down S0 bar over here along with I2. And for the last row, both S1 and S0 are 1. So just simply write down S1 and S0 along with the I3 input. So we have a 4 min term in the expression. Now using this expression, we are now going to draw the logic diagram of 4:1 multiplexer. Since everything depends on S1 and S0, so first draw the S1 and S0 line, and since my expression contain not only S0 and S1, it has also the invert of S0 and S1. So draw like this. This is the S1 line, and draw a connection, another connection which is an inverter, and it will be treated as S1 bar line. Similarly, this is S0 line, and this will be treated as S0 bar line. So this is invert of S1, and this is invert of S0. Now look at the expression. It has 4 min term. That's mean it contains 4 AND gate. Now you can draw 4 AND gate over here. For the simplicity of the diagram, I have not considered the enable line in my circuit. So just leave it for the time being. Just concentrate on the expression only by ignoring the enable line. Okay. Now in the first min term, it is written as S1 bar dot S0 bar dot I0. So what you have to do, you have to draw a connection from S1 bar line and S0 bar line, and I0 will be an independent input line. So it will be look like this. Look, the connection has been drawn from S1 bar line. This is S1 bar, and this is S0 bar line, and this is an independent input variable I0. For the second min term, S1 bar S0. So draw connection from S1 bar, then S0. This is S1 bar, this is from S0, and this is I1 line. Similarly, for the third min term, S1 dot S0 bar and I2. S1, this is an S1 line, then from S0 and I2 line. And the last term is the S1 S0 I3. So draw connection from S1 S0 and draw a separate I3 input line. All these AND operation are now connected with an OR operation. Look at the Boolean expression. So all these AND gate are connected with an OR operation. Now the output of all the AND gate will be the input of a single OR gate, and finally you will get the Y output. So this is the final logic diagram of 4:1. Now if you understand this 4:1 multiplexer, I think you can now design the higher order multiplexer like 8:1, 16:1 and 32:1 multiplexer. Subscribe to my channel Online Technical Mentor and press the bell icon for latest update.